So wonderful. Good afternoon, dear LinkedIn community, Composites Launch members, UCIA, ECA signatories. Today we are talking about a project within this UCIA. That is the Refresh project, and you can see all the details in this event today. We have 10 people today in this panel, so we will be rushing directly into the project. So what will be expected is we will explain you the Refresh project today. And yeah, my first guest is Rafael. Rafael will be introducing you now with a screen share. So I need to find him about the Refresh project. And you see already also other guests here, which I'm removing at this time because we will come back to them later. So Daniel is still in the picture, and I'll take them out also. So Rafael, thank you so much for organizing this wonderful Refresh project update. I've recently seen you have been also very, very active and traveling around like Tech Textile last week also, right? And yeah, within a tight schedule, you are also bringing up a Refresh into the minds of the people. Thank you so much.
Yes, but wonderful to be here today. Thank you for organizing. Ilkay, it's always a pleasure, and especially with this passionate topic about circularity of composites. So
absolutely. I will leave you the stage for now, Rafael. And
okay.
Yes, let's get started with Refresh.
Okay, so before talking about Refresh, because my colleagues will do it more deeply, it's just to share the vision of UCIA regarding circularity. And instead of having a lot of slides, only one. It's the picture as it is today about the waste volume reaching the end of life of the thermoset recycling, the thermoset composite materials. And as you can see here on this graph, we made some calculation some years ago. That's an interesting story. In 2018, UCIA had the vision to already started to evaluate what was the volume of recycling material, potential recycling material, meaning the volume of composite material reaching the end of life. And at that time, it was around 450,000 tons. They decided maybe not to communicate because they were not sure. Maybe it was not a good news. So we did again this calculation, updated the calculation in end of 24 to estimate what was the volume last year. And also we have some graph to show the trend. And now as we have probably started to evolve, all of us, regarding the vision of the end of life of material, we see it as an opportunity. We estimated that there is a kind of theoretical potential of 900 kilotons and 900,000 tons of materials reaching the end of life last year in Europe. And from there, we have evaluated what is the untapped potential, almost 230,000 tons, what are really available now. And those two numbers are very interesting to see what we are talking about. How big is the question? And also it's to motivate investors, waste recyclers, all the supply chain to come, because there is already something. And then the third number is also interesting. Only 5,000 to 10,000 tons are truly recycled today. So it's almost nothing. So it's where is about all our challenge, and it's why we are speaking about circularity. But the circularity today also is even more important because it will reinforce our resilience. We want to have the European community to be less dependent from imports from abroad, and it's also an opportunity to reuse at the end of the use of a material. You can reuse on different options. One of them is recycling, but before recycling, you have the reuse, the repurpose, the remanufacturing, all the R's maybe you know. So it means how can I have a new function for a composite material. And as you know, from the beginning, the composite material has been designed for performance, durability, and also lightweight. And that's why you can reuse the composite material for 50, 100 years. For example, recently I was talking with the boating industry, and we use in our calculation that the average boat life for the hull, for example, is 50 years. And one person actually from Finland challenged it, and he told me it could be 100 years. And he's right. No, you are always to take an average, because a boat which is 100 years is probably old-fashioned, so you have to redesign. But the material, the composite material itself, works for 100 years and even more probably. So we are all focusing how to organize the value chain to connect the people, and it's also what we have started to do with the European Circular Composite Alliance, to put all the stakeholders together and how to address it. So the point today regarding refresh, and the link to refresh is, refresh is almost 4 years old. So it means it was 5 years old that we started to think about this project. At that time, it was to demonstrate with what we call an holistic view, how can we recycle wind turbine blades, okay? And what is fantastic is that after almost the end of the project, at the end of the year, we see through the different technologies that, yes, it's possible. So today, it's not the question if it's technically possible, it's how to increase and to have to scale up a little bit the technologies. So you will see in these different, the technologies are ready. This project has been, personally, I learned a lot about the different technologies, whatever is mechanical recycling or thermal recycling. We have a huge investment, manufacturing investment, and that's also the passionate part of this, with all the the challenges when you go to commissioning or all these things. But we demonstrate through this project that it's possible. On top of it, and I will finish on that, is that we had also a view on the other possibilities to reuse the material. We did calculation of LCA. We see that when you do all these technologies, you can also reuse the resin, reuse the gas, which is also a value. So that's all about that. That gives a lot of hope for the future of the composite material.
So wonderful, Raphael. Thank you for introducing us to the refresh, and I can see your passion with the sustainability and circularity. And thank you so much that Lucia and your leadership, also Roberto Francine and your team, is driving circularity forward in our composites industry. Now, after a short break, Raphael, I would like to greet with you our panelists, each one of them. And please stay tuned. Just after this short break, we will continue with everyone here. So we have here, and right now, everyone who has the camera on. As you know, this will be over 60 minutes, so not everyone has the camera on, but who has the camera on is Andrea Tinti right now. Thank you. Welcome to our show. Then Ioana Munteanu, I hope I pronounce it the right way. Then Marcin Rushin, Giorgio Bettetto, Gonzalo Murillo, and Jan Kasper. And each one of them will be showing basically why they are here inside this refresh and what they are contributing to this refresh project. And almost everyone has also prepared a PDF, a presentation. Now, Raphael's presentation for some reason did not upload, but he made the screen share. So as you see, we are resourceful and we find always a way around. And this is the same with circularity. You have to be inventing things many, many times. So in my list right now is Daniel Crisenti. And Daniel is now also ready with the camera. And yeah, I will then continue with Daniel and take our panelists now into the backstage, and I will call you each one after the other. Is that fine? Okay. Yes. So Daniel, um, let's start with you.
Okay, so hello everyone. I am Daniel Grisenti. I'm the project coordinator of the Refresh project. So I will be giving you an overview on the project before leaving the floor to the other partners that will present in details their technical work and part. So quick overview on the consortium. So we have a total of 11 partners from 5 different countries working in our project. So basically, we have waste recycling and remanufacturing companies, engineering consulting companies, as well as research and development companies. And as Rina, we are coordinating the project, and we have UCA as a communication dissemination activities leader. So the project started on January 2023 and will end in December 2026. It started with the first design phase in which process and plants were designed. And then after the milestone, after the design phase, we are in the integration and deployment phase, which will be ending with the end of the project. So let's give an overview on what is the concept. Of our project. So the whole idea is that we start from the commissioning of wind blades in so the end of life wind blades, and we cover the whole value chain till the remanufacturing to new end products. So we start with the commissioning, and then we have different recycling treatments, mechanical recycling, thermochemical and thermal recycling, repurposing, and so on. And everything will be um, governed by the decision-making tool, which is an AI tool developed in the framework of the project that will decide for each wind blade dismissed and pre-treated to which route will be preferable in that moment for that wind blade based on market demands and also the conditions of the blade. So briefly explaining also the value chain and the partners so that so that you can see also our partners where are located in the value chain. So we have, as I said before, the commissioning of the wind blades and the pre-treatment, which consists of the pre-cut and the pre-shredding. We have ETAT9 and MTB for the first part. Then we have the recycling phase, which is divided in mechanical recycling from GIST recycling, the thermal recycling from Gencraft, Circe, and Ecolab for the dust recovery. So this leads to composite panels, recover fibers, chemicals, and energy from the dust recovery. And then we have the other companies like Setma, Tecnalia, and Acciona, which are covering the last part of the value chain into the applications and the final end product, like manufacturing of construction panels, 3D printed cement, repurposing, and other wind blades components. So This was a quick overview on the project. I will leave the floor to the other partner now that will explain you in detail what I have basically shown.
All right. Thank you so much, Daniel, for these insights. And let's continue then with Giorgio Bettetto from G's Recycling. Giorgio, I know already a couple of years. I have interviewed him already at Jack World. I think it was 2024, if I'm not mistaken, with very, very good results. And Giorgio has also very interesting solutions and also prepared a presentation. So, Giorgio, we leave the stage now to you.
Perfect. Thanks to all.
Okay, I have to escape somehow this. Okay, I'm sorry, I took the wrong one. For some reason, numbers are covering. So this is your presentation, Giorgio.
No, it's
let's
the
get.
Daniel one.
No, that's the wrong one. Yes, because it's still active with Daniel. That needs to go away, and yours have to come in. You see, community, there are a lot of presentations in my back stage right now, and I still need to get used to it. But this is Giorgio, I think now the right one, correct?
Yes, now I think that we are okay. I'm Giorgio Betteto. I'm in charge of the research and development of G's Recycling. On in background to me, there is the image of the new refresh production line, because we are industrial recycler of composites from many years with a proprietary mechanical process. And we started since Italy arrived very late in the wind industry, and now we are also starting in dealing with the wind blade waste that are very particular and different from the rest. A wind blade in practical is three different composites. We have the core part, the first part, the root, where it's all composite, all epoxy and fiberglass, very thick, very hard also to shred and to particle reduce. We have the transitional part where we have again a lot of hard composites, and then we have the blade part or the wing part where the quantity of hard composite is much lower, there are a lot of low density, and so also the composition makes different and requires ideally requires a different recycling process, because the core material makes all complicated in any kind of thermochemical recycling, because you may have at first for starting you have low density, so any kind of thermochemical recycling operate on a fixed vessel, fixed volume vessel, so the production is lower. Then you have a lot of different materials. We have found even 4 different core materials inside the blade. Our solution is to say, okay, let's use the thermochemical process where it's best suited, and we as use for making materials the mechanical process where we can process it regardless of kind of resin, fiber, or foam. Now we have a refreshing the production line. We have currently an industrial production, and we are starting the new production the new production line from refresh. In these days, we are making the trials, the production tests, and so on. But basically, we have found that it's possible to obtain panels something relatively simple, but where there is a really large market, better, faster, and more competitive with the refresh production line, with higher performance, and future, and not so much future because we are already selling to as alternative to MDF in plywood in different qualities in different applications. One of the things of most interesting in this kind of development we got is that we found that using the wind blade waste with a special developed phenolic resin coating, a low toxicity phenol resin, is possible to obtain a really interesting fire resistant behavior where we can add not just the fire resistant but also the smoke generation that is an order of dimension lower respect the alternative products, so no black smoke. And most interesting of all, it's also something where there is a very low degradation of the material. This is a cut of the panel that you see. And have you seen the fire penetrated for less than 1.2 millimeters after 5 minutes of propane flame at 5 centimeters? So we are having really good results. This makes much more possible really interesting application. For example, for building components, here we made a shading facade for a building in Venezia Mestre, where we went, it was an alternative to natural stone. So a third of the weight, half of the cost, and most important, no damage, no risk, for example, from ice or strong temperature. And apart of all, here we have 95% recycled content, 96 perfect. Other application where we are already making with a really interesting result, recycle, and we have started working with the components for cold chain and freezer, because in all these kind of application you have always water, humidity, and the quest is having at less thermal bridge that is possible. Anything that you put inside a foam create problems in the production, create problems when if it seems somewhat. So this is the recycled composite are the ideal material to make this. We are developing, and then with Chetma will tell more about this. We are developing also formwork for concrete. Also because I personally think that could be a really interesting application using complete composite formwork, for example, for the foundation of the new wind turbine, made with the scrap that come up from the wind turbine. Plus, we have also we are developing also interesting project or already in building, using also the recycled glass fiber that GMCraft make, using the profile from wind turbine and so on. It's possible to make a lot of things with composite, mostly for where you need something that with a long-term durability, low carbon content, and so on. Okay, I have. I hope to be to stop in the time, and I am willing to answer any kind of question here or later.
Okay, Giorgio, thank you so much. Right now, there are no more questions, but let me take the opportunity to greet our community that is plentiful watching our live stream right now.
Yes, I
And
think
I asked,
that refresh and AUCR work is a perfect example of what we need, not just for recycling of composite, but in general. A multi-layer approach. Here in the recycling world that I know very well, you have no universal solution. No, there is no panacea. You need all possible technologies and most focus in the market. So I think that refresh is the first start, I think, of something great that will develop further, because we've seen that not only there are a lot of interesting development, but there is a really value in the cooperation. Cooperation makes us stronger and permits to go further. Thanks to all.
okay, thank you so much. Very kind words of you, Giorgio. Now, Giorgio will now hand over to Marcin Rushin. Marcin, your PDF has disappeared. That means you need to upload it again. And while he's uploading it, I'll make a short advertising break, dear community. This is Composites 360 on Tour, your fast lane access to the global composites community. From factory floors to breakthrough labs, from startup powerhouses to industry leaders, we capture the people, the processes, and the ideas shaping the next generation of advanced materials. Where innovation meets real-world applications, we bring you the voices that define the future, directly, authentically, and live from the heart of every major composites event. In 2026 and 2027, Composites 360 on Tour continues its journey across Europe, bringing you closer to the people and breakthroughs shaping our industry. At JEC Forum Dach 2026 in Cologne, we reconnect with the German-speaking composites ecosystem, innovations, SMEs, suppliers, buyers, and industry leaders driving high-performance, lightweight solutions. At JEC World 2027 in Paris, we step onto the global stage, capturing world-class technologies, international collaborations, and the future of composites at the industry's biggest gathering. And at JEC Forum Italy 2027, we dive into a market rich in craftsmanship, innovation, performance engineering, and sustainable solutions shaped by Italy's industrial heritage.
Ilkay Oskizolo, creating sustainable value with Composites 360 on Tour. Weekly on LinkedIn, YouTube, and your preferred audio podcast app.
So, Marcin, we have also met at JEC World 2026, and I interviewed you there, right?
Yes, that's correct. That was a pleasure to have that talk with you.
And the Circularity Village it was.
Yes, we've been present there as one of the exhibitors in the Circularity Village. I think that was the first time they actually had such a village.
Yes.
It was very nice to be there and see all the partners working with the recycling of the composites.
Yes, maybe I can pick this topic up later, Raphael, with you. Prepare a short explanation about the Circularity Village and what UCIA has made. Marcin, now your presentation, I'm delighted to see, is now in the system, and I will show it here and leave the presentation to you.
Okay, perfect. Thank you. So, hi everyone. I'm Marcin Rushin, and this will be my quick walkthrough through what we do, what is our role, and what we do in Refresh, and also where are we heading as the company. So at the beginning, I would like to say a little bit about myself. So I'm a co-founder and currently running as a CEO of Yencraft. So my day-to-day is about driving the technology development, taking it from the lab into the industry scale, building up and commissioning our plant, and networking, connecting with the European actors in the composites industry. And now moving to the more interesting part, which is Yencraft itself. Yencraft is a Norwegian recycling startup, which is based in Høyanger, one of the Norway's deepest fjords. We are founded in 2011 with a clear mission to solve the growing challenge of composite waste in renewable energy. So our timeline said best. We are recovering, reversing, sorry, end of life. We turn end of life wind turbine blades into usable resources, new materials for the next generation of composite products. The technology behind our solution is innovative, scalable thermal recycling process. It is sustainable and economical with a patent pending. And we are industrial partner in Refresh, bringing the real plan operation to the project. Before I dive into our role in Refresh, I would like to say a little bit about our journey and the context. So we started up long before the Aircraft was formally founded. We started developing our technology 2020s. Next, in 2022, we have moved into the pilot operation, validating the process at magnificent scale. And then here is where Refresh came and helped us to actually move from the pilot into commercial scale. So now we are entering this phase when we are scaling up and building up our plan to deliver composite recycling at industrial and commercial scale to the market. So we are going nearly to 3,000 tons of composite waste throughput in our plant. And next step will be for the expansion. So our role in Refresh is pretty straightforward. We continue development of our technology and scale up our plant to put it into the operations. So there are those three things that we've been focusing on. In process development, we took our multi-step thermal route from end to end and make it to work at scale. So the wind blade arrives, and what will come out are the clean fibers plus oil and gas. Second is the scale-up engineering work, where we tune the pilot plant into the industrial design at scale. So boring engineering work to make a commercial plant actually working from day to day. And the last one, which is the most exciting, is actually to take those drawings and documentation and just put it into real equipment, real working facility with the high volume throughput and possibility to recover recycled materials for the industry. So the photo you see on the right is not just a plan, it's a reality. We are now finalizing the commissioning of our plant and moving to operation, where we will produce pure glass and carbon fibers for the future composite industry. So our ambitions, where we are heading, so we have three goals. We want to deliver. So the immediate job is to prove circularity and industrial scale alongside with our Refresh partners to demonstrate with the real data that the wind blade can actually become next generation composite products. Then the scale, which is also beyond Refresh, we want to become Europeans' leading composite recycling supplier. So our roadmap goes from today first plan towards nearly 100,000 tons of composite by 2036. So we have ambitious plan how or when we want to go in terms of our not one but multiple facilities, hopefully multiple facilities across the Europe. And we want to deliver the recycling backbone to automotive, maritime, maritime and automotive industries to actually move forward with the composite recycling. And the last one is the biggest one is actually to transform. So we want to drive the change. We want to power the new raw materials to turn yesterday's waste into tomorrow's resources and make recycling of composite the default, but to composite the industry, not exception or not something nice to have, but actually something to be a standard for the entire industry. Yes, actually that's all from me. So thank you very much for having me and letting me to say a couple of words about ourselves.
So thank you, Marcin. That was really refreshing as this show is going on. Yeah, you are also a partner of Owens Corning, as
Yes.
it is called still today. I think any time soon, Owens Corning will change its name, the original composites company.
That's the plan.
Yeah, tell us about your partnership with Owens Corning. What is your role there?
Yeah, it's a great collaboration. It's actually one of the first customers to us on the downstream with the scale. So we are talking here about delivering big volumes of the recycled fibers, recovered fiberglass, to Owens Corning, or whatever they will be called in the near future, to remelt the fibers into new virgin materials. So by collaborating together, we are solving one of the challenges there is in the composite recycling, the downgrading of the recycled fibers, because the glass fiber that are coming out from the recycling process, they are not exactly the same as the virgin fibers, of course. I think, first of all, they are reduced in size, right? Because the material that is coming, the fibers, when they are used in the products, they're already cut, they are shaped, so they cannot be used exactly the same as the virgin fibers. So with the collaboration with Owens Corning, we're actually able to close the loop. So the fibers become the fibers again, continuous, that can be used exactly the same as the virgin fibers, with the difference that they contains a high recycled content in the material. So that's pretty exciting. So we are looking forward to deliver those materials to Owens Corning, actually see how they turn back into their virgin fibers.
Okay, wonderful. So thank you one more time, Marcin. And I'm greeting now Gonzalo. And before we start with Gonzalo, my question to the panel here is, there is Vitaly asking this question, curious to hear from people working with composites. Can you write me, please, in the private chat here who can answer this question? I have an opinion certainly on it, but we'd like to hear from your expertise. If someone has a special expertise on this, please write me in the chat who would volunteer to answer that question. And yes, so without further than delay, we take Gonzalez into the picture. Gonzalez, I say, it's Gonzalo. Gonzalo.
No problem.
Murillo Jordia. I hope I pronounce it the right way. You're from Spain?
Yeah.
Yes. CIRSE, Centro de Investigación de Recursos y Consumos Energéticos. Does that sound a bit Spanish? Yeah, I've been long time now to Spain, but in the past I was a lot of times in Spain. So it's like riding bicycles; it comes back. Yeah. So Gonzalo, yeah, you have also a presentation for us.
Yeah.
And I would say, yeah, let's keep it. Let's go. So where is the presentation now? Gone. It's here. Okay. Yeah, you need to go back, and it's cool. Yes.
Okay. Thank you very much. So good morning, everyone. I'm Gonzalo Murillo, and I work at the CIRSE Technology Center, which is located in Zaragoza, Spain. CIRSE is composed of over 300 professionals focused on bringing innovation closer to the business sector. CIRSE bridges research and the industrial sector in the fields of energy, sustainability, and circular economy. And we support promising technology developments through public funding, working with industrial partners and transferring the results to the companies. More specifically, I work in the Industrial Recycling Technologies Department at CIRSE, where we have experience on the intensification of thermochemical processes through the use of microwave heating. But why using them? When working with conventional heating, has to be transferred from the outside to the inside of the material. But when working with a composite material, this can be slow and inefficient because the resin has poor heat transfer properties, leading to temperature gradients and lower control over the process. Microwave heating offers a different approach. It can be much faster and more selective, and it allows us to heat selectively the materials that absorb microwaves, giving better control over the process and potentially over the composition of the oils produced. This expertise defines our role within the Refresh project, where we are applying microwave-assisted technologies to support the recycling of wind turbine blade composites comprising pyrolysis, but also solvolysis. Both routes aim to recover valuable products from the composite waste, glass fibers, and oils. The oils could potentially be used either as fuels or as chemical building blocks, depending on their final composition and quality. To conclude, our next step are focused on generating reliable technical data to support future decision making. So we want to assess the energy performance of microwave-assisted processes, understand how they influence product yields and oil composition, and compare their advantages and limitations with conventional technologies. In this way, the project will help to clarify where microwave-assisted recycling can add real value for the treatment of wind turbine blade composites. And that's all from my side.
Okay, thank you, Gonzalo, then for this short recap. Yeah, and I got now Jan Kasper also into the picture. Jan, welcome from Eneco Lab.
Yes, it's an Ecolab, and it's a small company which is located in Italy, Trieste, north of
All right.
Italy, just close to the border on the sea, Mediterranean Sea. And
Very good,
what
very
we
good.
are today talking about is still on the formal treatment. You should put my presentation on, please.
Yes, the next one is coming. So
Okay.
this is so this is the presentation of Jan, and welcome, Jan. Now
I would prefer starting from the beginning, possibly. So that's now okay.
yes.
So, as I said, chemical treatment of dust and fines is the specific task of our company. And the point which is interesting in this sense is that dust and fines are the residuals of nearly every kind of processing of the blades. You have to cut them and so on. And actually, they can represent a very large part of the starting materials. And clearly, in the present roads are unfavorable from the environmental point of view because either in the coal in cement factories, if permitted, or landfill is essentially the way how they are how they are their disposal. Our process is simply a pyrolysis process, which is essentially running at high temperature in order to produce mostly a syngas as an energy carrier and inerts. If we talk about the pyrolysis, which is very often used in the valorization of this disposal material, but the point is that you have different kind of products being formed, which are the gaseous part, the char, liquid part, and an organic solution. Clearly, in our case, is the glass. Now, why going into the high temperature reaction? Because as you increase the reaction, you improve the yield in the syngas, which is then can be used as an energy carrier, either to generate electricity or heating or other parts. But the residual solid typically gives out the inorganic inerts. You have to keep in mind that we are using dust and fines, so the gas which is being formed is less interesting because the fiber is nearly destroyed. So the objective is to maximize the yield of the gas, which is the easiest energy carrier to be used in our case. So what you see here is an example of our pilot reactor, where you feed the material into the pyrolysis furnace, and then you have recovery cleaning of the gas. And here at the right, you have an example of what are the yields, or in our case, clearly the pyrolysis is a general process which you can use and optimize, and this is our role in our project to optimize the yield, as I said, of the gas using the wind blades residuals. I think that the intrinsic point is essentially that under clearly you don't have the comparison of the energy consumed and the energy obtained. It seems quite low in this case because why that? Because the wind blades have a large amount of inorganics. Clearly, as you can see in our processing, if you use, for example, from HPL, which is high density laminates residuals, you can obtain quite high yield of the energy compared to that use. So point is, you can use within which is the result of what we say. We see that we can efficiently convert the dust and fine grains, but most important, this process is designed as a part of an integrated industrial process in the processing. FOGs, for example, is now will be using our plant in order to recover energy from the dust or from the part which cannot be used in other way. So it's complementary as a project to what we have seen so far. So I wish to thank you for your attention, and if you have any question, I will be happy to reply to you.
So thank you, Jan, for this introduction. Very, very valuable. And now we are getting also Andrea Tinti into the stream. So let me see, Andrea. Okay, Andrea is here.
Good morning, everybody.
Good morning one more time. And Andrea was a bit worried about the mirror-like effect of StreamYard, but as you can see, Andrea,
Everything's right.
Everything is fine. We can see Setma very well. Yeah, you have also a presentation
Yes,
prepared,
please.
and this is your presentation. Andrea, the stage is yours.
So, good morning, everybody. And first of all, Ilkay, let me thank you again for this great opportunity disseminating the work done in a research project. My name is Andrea Tinti. I'm representing CETMA, a Center for Contract Research and Advanced Engineering Service based in Brindisi, southern Italy, that has been working on polymer and composite materials and related technologies for over 30 years, since 1994. The best way to introduce the role of CETMA in research is to have a look to the project value chain. CETMA is coordinating development of new products from end-of-life wind blades for several applications by using eco-design methodologies. So in the next few minutes, I'll share key insights on 3 representative case studies we are working on based on as many different recovery routes. So first, in blue, we have application of secondary raw materials from thermal recycling, in particular recovered glass fibers to be used as a part of a new wind blade components. In green, we have application in building and construction of mechanically recycled composite panels, and finally in yellow, repurposing of full blade parts after only minimum reworking with application in urban furniture. So the first case study that we have called the circular wind blade is a very multi-partner case study involving not only refresh partners, but also external stakeholders, allowing to build up a full product supply chain. Basically, the thermally recycled glass fibers were reprocessed into a non-woven mat that has been used as non-structural part in a new wind blade layout. So in a really closed-loop approach. A full-scale section demonstrator has been manufactured that has been exhibited to the Innovation Planet at the JEC this year. And in the next months of the project, numerical validation and life cycle analysis of the over the whole product value chain will be assessed. Next, the second case study is probably the one currently closer to the market. This is the framed formwork for shaping vertical concrete walls and columns. The concept was to substitute the outer sheet, traditionally made of plywood, with a mechanically recycled composite panel. A numerical study has been developed to model a frame formwork based on recycled panels by modeling the fresh concrete static pressure and the resulting out-of-plane deformation. The formwork elements have been manufactured based on the optimum numerically modeled design, and currently experimental validation is in progress to real testing on worksite environment. And finally, about repurposing, our general idea was not to limit our effort on urban furniture items with just, let me say, self-supporting furniture like the picnic table we developed based on a previous study, but to try exploring more structural application that could take advantage of the residual mechanical performance of end-of-life components. For example, a cash cushion. Again, so a numerical study has been developed to evaluate the technical feasibility of a cash cushion based on a number of wind blade sections recovered from a reference blade model. Virtual cash tests have been run in different configurations, showing promising results in terms of vehicle impact severity indexes. So in the last part of the project, demonstrative prototype will be physically assembled, most of all for dissemination purpose, opening the door to future improvements within the dedicated project, possibly involving sector stakeholders. Of course, there's no time to go into more technical details. What I wanted to outline this short presentation is that with today's knowledge and technologies, recycling of composites and also other virtuous recovery routes like repurposing are not only necessary in the framework of circular economy, but also widely possible. And Regarding potential applications like those shown today, the only limit in the end is imagination. Thank you very much.
So that is a good statement. The only limitation is the imagination. Wonderful, Andrea. Yes. So Raphael is next in line one more time with Anurag Bansal from Acciona Construction. Do you want to share, Raphael? I see it. Okay, you got the. Okay, I need to
Yes.
stop first Andreas share. And now I can put your share on. Yes, and let's start then with Acconia. Raphael, the stage is yours.
Thank you very much. So, of course, I'm not Anurag Bansal, who is very famous in the composite industry. It was not possible for him to attend this session, and he asked me to go through his slides. So I don't have the talent of Anurag first, and not, of course, very difficult for me to speak on behalf of Acciona, but I can go through what they achieved. And Acciona is in the construction market, they are saying, for more than 100 years. And what was very interesting to have Acciona in the Refresh project is because they have the need of they know the construction market, what are the needs for the construction market. On the other side, they have developed over the last 20, 25 years wind blades, so they are in the composite market, and it was the perfect link of how can you combine the end of use of a material having a new life through the construction market. And really having Acciona and Anurag part of this is a big advantage. Okay, so the role of Acciona, who is more at the end of the Refresh project, is when you get the raw material and what you do next. And that's where they are developing different functional prototypes. And I go to the next slide to show you. Oops, no, that's my moving. So 3 different projects. One is to use the milled wind turbine blades and to make pultrusion out of it. So this is something now they do it at, I would say, industrial scale. The second one is the production of non-woven fabrics. And earlier, Ilkay was mentioning, I know that if Anurag was at Textile last week, which is the largest world event for technical textile process and actors, he was also looking for some solutions, and they are almost done regarding this project to produce non-woven fabrics and then to be used in production of a composite part. And the third one, as also Andrea was showing, that's the formwork system, which is a mix of their different technologies they have to produce the formwork. So having such large construction leader in Refresh was really a big advantage. And when I was asking Anurag where they are in the prototypes, and because the project ends at the end of the year, and they are very confident to succeed on all 3 projects by the end of this year. So that's also gives, it's no longer a prototype, but it becomes reality. That's what I can say on this.
Okay, so thanks for presenting Anurag's solutions then. We have one question, and Marcin, please prepare yourself because you were recommended to answer that question, and I'll take you in a minute onto the screen. Meanwhile, also my message to David Garcia Estevaz. You are also watching us on LinkedIn. Please make your way now into this backstage before we move to Iona Muntean. So, Marcin, we had, I'm sorry, I muted you. Now you are back. We had a comment from our community from Vitaly Kardash, and I will show it. So, he's curious to hear from people working with composites. What are your key quality requirements for recycled glass fibers? We are currently recovering relatively long fibers via pyrolysis, but they still have some carbon residues on the surface. We are working on post-processing cleaning, but would love to better understand what really matters for your applications. Happy to exchange. Do you have an opinion on this, Marcin?
Yes, so as I understand, Vitaly is running similar process to our. So the answer is not simple because the quality of the fibers and the purity of the fibers is dependent on the application and the needs of the customers. So it's a iterative process that needs to be taken with the market. And this is what we are using a lot of energy to work with the industry, to work with the markets, to work with the off-takers, to understand what they need, what kind of quality of the fibers they need in terms of physical parameters like length, purity, in terms of the composition of the surface of the fiber itself, and the treatment of the fiber. So it's my advice is to Vitaly is to work to find the market, find the off-takers he wants to work with, and that find interesting working with them, and find out what are their expectation requirements. Since recycled materials are not, let's say, on the market right now in the high volumes, and the off-takers, the companies working with the composite do not have the experience working with that kind of materials, they need to learn. Everyone learning how to use the products. And when we speak to different off-takers, each of them has a bit different requirements and a bit different application for the fibers. So it's not easy to answer. There's no easy answer. It's just work with the market, work with the network, and find out what is the right application for the fibers you are recovering, Vitaly.
Okay, wonderful. Thank you, Marcin, for then joining and letting us know. Of course, sometimes it's difficult to give recommendations to the colleagues that are in the same or similar fields. So I really appreciate your answer. What I would like to maybe add to this is once you recycle glass fibers, I mean, a glass fiber has a chemical composition, and that chemical composition should stay largely as the fiber itself intact, of course. So I would suggest make a chemical analysis of the glass fiber. And coming from the textile background, if someone wants to use it not just as a chopped fiber, but maybe in a glass fiber for textile applications, like in chopped mats or something like that. Of course, the surface is also important. The surface should be treated with a binder, yeah, and things like that. So you would need to probably also treat the surface of the fiber. This is something I would like to add with a textile background, without knowing how long is the fibers, is it still in a roving form or not. Okay, thank you so much. So we got now Joanna, and Joanna, where are you tuning in from today?
Sorry?
From where are you tuning in today? From where?
From Italy, Bologna.
Bologna.
Yes.
Ah, okay, cool.
Yes.
We had been with Jack Forum in Italy, in Bologna, in 2023, I think.
Nice.
Yes, and then it was in Lake Como, and now next year it will be in Torino. Will you be in Torino also?
I should be in Torino, I guess.
Okay, then we will meet personally. So you have also prepared a presentation for us?
Yes,
and
correct.
Let me check. Yes, it is on, and then I will leave it to you.
Okay, yes, thank you. Thank you very much. So I'm Iona Muntian. I'm working in Rina Consulting. Rina is an Italian-based company providing engineering and consultancy services worldwide. I'm an environmental engineer and I work here as a sustainability consultant. Inside Refresh project, we from Marina, we are provided uh, among the coordination of the project, which is led by my colleague Daniel Grisenti, which previously introduced the project. We are also responsible for the sustainability analysis in this project. So basically, we perform life cycle assessment or economic or social assessment for each recycling process developed in the project and also for end products. So we will talk a little bit about some results that we um, reached so far in Refresh project. So I bring to you this topic, which is the preliminary life cycle assessment results that we conduct in this project. So we basically analyze recycling processes developed inside this project, and we use this life cycle assessment methodology, which is a methodology that follows internationally standardized procedures, and it's basically a type of analysis that it's grounded in a framework which is divided in 4 phases, right? So we have the goal and the scope definition of the analysis, which is the 4th phases. So we decided to conduct this analysis on these innovative refresh recycling processes. Then we decided also in the goal and scope definition that we wanted to see how recycling processes behave from environmental point of view with respect to linear disposal technologies, but we wanted also to see um, which are the environmental benefits that arise from secondary raw materials that are produced by the recycling processes, right? So we set the functional unit for our analysis inside this project, which is 1 ton of wind turbine blade to be recycled, so end of life wind turbine blades. Then we move further to the life cycle inventory, and we based this inventory on high quality experimental data, which was provided by our technology providers. This data mainly comes from on-site testing, so real and very good quality primary data. Then we use EcoInvent and Sphera LCA databases for other flows that we need in our analysis, and put together these nice inventory tables that then we feed into lifecycle calculation software, which is called Gabi. We use this software for to perform this type of calculation, and then we run the impact assessment, looking into resource consumption, the global warming potential, so the famous CO2 equivalent, and the waste production. Then lately in the interpretation phase, which is the last phase of life cycle assessment, we perform an hotspot analysis. So we wanted to see in each analyzed process which are the main hotspots that generate environmental impact. Yeah, and then we have the comparison with the linear disposal, and then we have the a first preliminary environmental benefits. These are the system boundaries that we apply in our life cycle assessment study in this refresh recycling value chain. Basically, you can see that we have the recycling in the red rectangle. So we consider inside our boundaries the mechanical recycling process, the thermal recycling process, both with the pyrolysis, that one performed by Giencraft, and that one the microwave pyrolysis developed by Circe. So these are our boundaries in this study, and let's see some results, which I think is the most interesting and important part also our analysis. So basically, if we want to see how recycling behaves with respect to traditional disposal methods, from environmental point of view, we can see that in the climate change impact category, all refresh recycling processes shows lower environmental impact than landfilling or incineration. But we know also that recycling processes produces secondary raw materials that are capable to substitute virgin production, and this substitution leads to further avoided greenhouse gases emission upstream and amplify the climate benefits beyond those shows on this graph. Another comment on this graph, we compare the mechanical recycling process with the landfilling, and we compare the thermal recycling process with the incineration, because we choose it to have this type of comparison because are more similar, thermal recycling with incineration and mechanical recycling, which is mechanical process with landfilling. This is my last slide, and here I would like to bring up to the audience the fact that the recycling processes produce secondary raw materials. So all the recycling routes analyzed in this study deliver large climate benefits because we basically avoid virgin material production. So we have that mechanical recycling deliver the largest net reduction. We are almost in the order of 3 tons of CO2 equivalent. But also the thermal routes also deliver substantial net reduction, nearly in the order of 1 ton of CO2 emission. I finished my presentation. I think that sustainability, it's becoming central also in this sector. Thank you for your attention. I would be happy to answer to your question or curiosity if you have. Thank you.
Thank you, Joanna. It's very always good to see how frameworks are applied in the real world. And now, community, we are coming slowly to the end. And before I move to David, let me check one more time your comments. Thank you so much. You've really engaged a lot. A lot of links are in the comments. Please check them out. Yeah, so you have really the full information on what's going on. And yeah, David, you have also prepared a presentation, and I will get now your presentation also active here on the screen, and we leave the stage to you.
Okay, thank you very much. Hello, everybody. I think we are arriving at the end of this presentation, so I will try to be very brief. My presentation is about 2 other solutions delivered in Refresh project. First of all, let me present my company. Technalia is a research center. We have long experience dealing with the recycling of composites, large composites as wind blades. And we work in several industrial areas with the objective of providing solutions to companies. Our mission is to deliver, to transform knowledge into solutions for society and companies. In this project, we have 2 different roles, 2 different types of activities. First of all, we are leading one traceability platform to support the circularity of the wind blades from the end of life, even when they are still in the wind farms, until they are totally reintegrated into new products and materials. Second, as I will explain later, we are also developing some 3D printed concrete solutions using some of the recovered fibers. For the first solution, traceability, this includes several aspects, as you can see in this slide. We think that traceability is a key enabler for circularity. So we are not just developing another traceability, another platform, another piece of software in general, but we want to provide some real solutions for the market. So for this, we are using, among others, blockchain technology to provide a secure, decentralized system. But perhaps for most of the audience and potential users of this platform, it's relevant to know that we are also developing it with a very clear view of be something practical, easy to use, and that can be directly applied in current market operations. So we have also considered for its developing a friendly user interface, clear dashboards. The relevant information can be stored there. And of course, we also considered the specificities of the wind blades value chain. We believe that platforms like this can support regulation and certification and can enhance transparency and at the end customer confidence, which is necessary to ensure the market acceptance of the recovered materials. The platform was developed last year, and at this moment we are sharing the access to the platform with refresh project partners. But in the future, our aim is to also give access to anyone interested on this. As a second solution, we have used some of the fiber recovered in the project, both the mechanically recovered fibers that have still some resin covering those fibers, and also the clean fibers obtained after pyrolysis. In the past, we have used successfully those fibers, similar fibers, for manufacturing precast concrete elements. And in refresh, we want to move one step beyond, and we are testing those fibers for manufacturing 3D concrete printing. As you can see on the pictures, we want to be ambitious, and we want to also manufacture dowels and towers that hopefully can be used in the future also in the wind sector. I will be open to any question or discussion on this, so you can find my email at the end of the slides, and I think it's enough for a brief idea of what we are doing in this project. Thank you very much to the audience.
Okay, David, that was cool. Thank you so much for your presentation. Short and quick towards the end. Dear community, I will ask you for 2 more minutes because I would like to discuss with Raphael 2 things. And first of all, Raphael, the Circularity Village was mentioned today. We had GenCraft there. Estelle also was there, your colleague. Tell us about what was the idea of you having a second booth at JEC World with this Circularity Village? You're muted.
Okay. First of all, thank you to all my colleagues to go through the presentation of Refresh. Before answering your question, it really demonstrates that the industry is ready, and that's really was the purpose of this project. So congratulations to all. To your question, JEC, is as Giorgio Bedetto is using it, la Mecca of composites. If you. The JEC decided that speaking about composite material needed to also address circularity, and having a focus on the circularity village with different solutions, as GenCraft was also there, was essential, because today we speak about this industry, what are the value of this industry, but also what is happening at the end of use. And don't want to repeat myself from the beginning. And for us, as we know, we have a close partnership. We also with JEC, I would call it a strategic partnership as a SIA. It was also important to be there because a year ago at JEC or so, we launched the idea to have the Circularity Composite Alliance, the European Circularity Composite Alliance. And 1 year after, it was the possibility to demonstrate what we are doing. After launching this mid of the year, with the support of the European Commission, who is, I would say, watching us and following us, that's very important that we demonstrate what we are doing all together. And being at the Circularity Village was to present the initiative and where we are after less than a year.
Okay. So the second question, Raphael, I'm having to you is actually two parts of the second question. The first part is the refresh. Where is it going this year? Do you still have meetings going on? How is it organized? And then I would like to pre-announce our next LinkedIn Live. The date is not yet fixed, but it will come soon on the Aeolian project. If you could give us a taste and a flavor of both parts of this question.
Sure. So refresh, I think we are all saying, okay, it's already the end. We'll stop at the end of 26. So we still have a few things to demonstrate. We have our next General Assembly in 2 weeks in Norway, where Genkraft is located in front, very nice area. So it will be an opportunity also to see their latest investment in pyrolysis oven. That's so as Marcin has demonstrated. And the next, so we are also involved in another project, which is Aeolian, which is also the development of Vitrimer. Vitrimer is the advantage of thermoplastic and thermoset resin, if I would like to make it very short. And this is also a very interesting project. It's a 3 years project. And yes, we will have a live interview, the same, I don't know, it's Amanda who is managing it, so I don't know exactly when it's in June, I think, but I don't have the day on top of my head. So stay tuned, because it's also a way to introduce new way of producing wind turbine blades with a new type of resin around the Vitrimer, and also using some the digital systems. Okay.
Yes, the date is not yet clear. It is in the discussion. And I'm getting now everyone finally one more time in. One missing is Daniel Grisenti. He has the camera off. So Daniel, once you have your camera on, it's the case now, I will put you into the stream. So thank you everyone. It's quite a number of people. I have seldom so many people here. Community, usually StreamYard accepted 12 people, and we had actually 12 people planned and lined up. And suddenly it is reduced to 10 people, the live stream, and we had to juggle a bit around. So Marcin, okay, still here. Yeah, I think everyone who was supposed to be here is now here also. So we are lucky that there was a natural decrease to 10 people right now. And my final round is traditionally here a so-called call to action. What is a call to action? A call to action is actually what should people now that having watched us, and we had plentiful people watching our live today, most people will see it now, watch it on replay this evening at prime time, when the kids are in the bed and before they go and they've seen the news on the TV, they will watch this live stream, maybe today, maybe tomorrow, or the other days. And also this live stream will be also available on YouTube, so you can watch it on YouTube. And it's also available as an audio podcast. So all our podcast guests that are listening right now, also hello and happy day to you. So a call to action is, what should people do after they have listened to all what you have said? And everyone gives us a call to action, to your free choosing. Raphael, I will jump over you. You will be the last in this line. We start with Andrea Tinti. What is your call to action? What should people do now after they've watched this?
Well, As a leader of new product development, the goal of CHETMA was to facilitate networking between stakeholders and to build up new product value chain. So my invitation for the audience is if you have any idea of new product based on recovered composite, maybe at a lower TRL, don't hesitate to get in contact with us. So, let's see what we can do together to bring that solution closer to the market. But
okay, thank you,
that's
Andrea.
the invitation.
Then we move to Iona. Iona, what's your call to action?
Yeah, my call to action is to be more aware about the sustainability in their processes or in their product development.
Okay, good. Jan Kasper.
Well, I think that what we have shown today that many of these roads to recycle, at the end of the day, you have quite a waste which is hard to be used. So be aware of that. If you can recover at least energy or as other do starting material, that's an important point. Think about it.
Absolutely. Thank you, Jan. Gonzalo.
I think that I talk in the name of everybody when I said that we encourage you to share your needs and challenges so that technology development can better match the real industry requirements. And it would also be very valuable to explore potential collaboration across the value chain from material recovery to end-use applications.
All right, Giorgio.
First, thanks to all, and particularly to Ilkay and Composite Lounge. That is one of the best places to get information, because one thing that we need in general in composite is to make more awareness, because composites are the best possible solution for sustainability, for cost, and for and the future of composites are the recycled composite, because simply this would allow to have more recycled product and less costly product. So arrive with the composite have a lot of advantage: lightness, weather resistance, low maintenance, and so on, will be more. The second thing, network. There are a lot of important things in Refresh. There are a lot also of important results in other projects, and the best. So contact us, share more info as possible, and make this a constant of every day, because it's surely something that will give only good results. Thanks to all.
Thank you so much. Marcin Rusin.
Yes, my call to action would be that if you specify, buy, or build with the composites, think what would it take for you for recycled glass fibers to become your default choice, not only the exception. And with that, contact us with that thoughts and see what we can do together.
Okay, wonderful. David.
Hi. So my recommendation, as someone has already mentioned, is to check the information. Change your mind. Don't think that wind blades are still unrecyclable. Check what the industry is, how the industry is progressing. Now I have received another news related with this topic. There is a new industrial plant for recycling blades in Spain. So realize that the scenario has changed a lot in the last years, and solutions are arriving to the market.
Okay, cool. So before we move to Rafael, Daniel Crescenti.
Okay. No, my thought is that now, I mean, the project is ending formally on the end of this year. So I think it should be good to explore then further collaborations for other projects in this environment, because the composite recycling, I think it's becoming something more and more promising. So it's worth exploring further and not leaving Refresh as a beautiful isolate case study, because it has to be continued.
For you, Raphael, I have a QR code. This is this one here. And community behind this QR code is one of my passionate memberships, the ECCA, European Circular Composites Alliance. Yes, Raphael, you have two call to actions. One is about Refresh, what we discussed today, and the second one, please, on the ECCA.
Okay. When you're the last one, I was saying, I hope no one will steal my idea about the call for action, what I wanted to say. But obviously, it has been said. But in short, don't hesitate to choose composite for all the values of composites and about decarbonation and sustainability, because today the industry has solutions. And what has been said was interesting. It was not maybe the case 5 years ago. We were hesitating. Today, the industry has the technologies. We just need to organize ourselves. And it's also about awareness. And that's, thank you, Ilkay. Thank you, Jack. And I would say also, thank you to the European Commission, to funding, and to gather all together, because, we are always, as public, sometimes complaining about tax and all these things, but you see the value of this support is essential to gather all the industry. So the next things is our message regarding the thank you for the QR code. Of course, I did not recognize it, but the European Circular Composite Alliance, as I said earlier, is the place if you want to accelerate the circularity of composite material. If whatever you are in the value chain, if you are a recycler, if you are, I would say, producer of composite parts reaching the end of use and saying, what can I do next? That's really where we have today more than 200 companies organized by working groups, different working groups per markets, and we are really addressing it on a very pragmatic way. That's also something we don't want to have meetings just to talk, but also to act. And that's, for example, a month ago, one of the group has visited the dismantler of cars to see what are really the issues. Some others are working on a very specific survey to really address the specific blocking points. And another one is also preparing some policy ask for the Commission, because we also need them on some regulatory framework and to evolve. So that's, join us anytime. You are very welcome.
Okay.
And thanks again.
You're welcome. You're welcome. It's my pleasure always here to serve the community when it comes to innovation, technology, and sustainability. Thank you so much. So everyone in the backstage, have a nice day. Please make sure that your recording is at 100%. And now there's an outro of about 2 minutes, and we will conclude this session. And as we announced, there will be another LinkedIn Live, probably early July now, about the Aeolian project that Raphael has indicated to you. Thank you so much, and bye-bye. How do we connect you with the stories within the composites and sustainable materials industry? We are on the ground to find the facts, and we examine big innovative ideas. We let perspectives on technology and sustainability emerge and ignite conversations that matter most to bring you the composites and sustainability world to you. Stay informed, stay connected, stay inspired. From our online studios in Germany, we cover events and corporates from Germany, France, UK, Central Europe,
Italy, Turkey, and other European regions. Join us for creating sustainable value.
This is Composites 360 on Tour, your fast lane access to the global composites community. From factory floors to breakthrough labs, from startup powerhouses to industry leaders, we capture the people, the processes, and the ideas shaping the next generation of advanced materials. Where innovation meets real-world applications, we bring you the voices that define the future, directly, authentically, and live from the heart of every major composites event. In 2026 and 2027, Composites 360 on Tour continues its journey across Europe, bringing you closer to the people and breakthroughs shaping our industry. At JEC Forum Dach 2026 in Cologne, we reconnect with the German-speaking composites ecosystem, innovations, SMEs, suppliers, buyers, and industry leaders driving high-performance, lightweight solutions. At JEC World 2027 in Paris, we step onto the global stage, capturing world-class technologies, international collaborations, and the future of composites at the industry's biggest gathering. And at JEC Forum Italy 2027, we dive into a market rich in craftsmanship, innovation, performance engineering, and sustainable solutions shaped by Italy's industrial heritage.
Ilkay Ozgizolo, creating sustainable value with Composites 360 on Tour. Weekly on LinkedIn, YouTube, and your preferred audio podcast app.